Thanks again. So we will move to the next presentation. I would like to invite Mr. Paitrault to join in. Mr. Paitrault from the company Spherea. Thanks again.
Good afternoon. Thank you very much for inviting us in this conference. In this presentation, we'll talk about rapid prototyping solution developed by Spherea, its capabilities, and how it can be adapted to become a serial product. So, wow. Can you go back for once? Thank you very much. First, quick introduction about me. I'm Florent Paitrault, in charge of the research and technologies for Spherea. And concerning Spherea, we are a company specialized in test system solutions, used mainly in the aerospace industry, but also in the railway industry. Next slide, please. So why this presentation and why this product? First of all, it's we have developed this product in order to address new developments concerning the predictive maintenance and autonomous train, and also in order to introduce and adapt those new technologies inside railway industry, and how to reduce time between this technology and how we can use it inside the real environment. So for that, next slide please, we have developed a solution that is compliant with the railway standards in terms of environment conditions by providing a platform fully compliant with the environment standards, and also in order to assist the end user, we have provided inside the platform a full environment allowing to integrate directly MBSE-based model developed by various simulation environments, for example, directly inside the embedded software. That's allowed to directly get an idea, a new technology, for example, a new RF solution, geolocalization technology, and adapt it, develop a software by using traditional or new MBSE development solution, and embedded it directly inside the railway platform, and very quickly, with a very short time, put it directly inside a train, for example, and check its behavior in a real condition. Moreover, we have added various user interface allowing easier operation and maintenance operation, which are very important when we are prototyping a new technology or testing a new software, new system inside an embedded system. So we have provided a web server interface, for example, that is directly accessible by using the equipment Ethernet connection, or for example a Wi-Fi connection by using a laptop next to the embedded equipment. And moreover, we also have provided a full toolbox allowing post-processing of data acquired by the embedded system. This kind of equipment has been developed for a very wide range of applications. So it can be used for example, system health monitoring, but also to integrate LTE communication to a ground center. We are going to embed also GNSS navigation inside the equipment, and provide many parameters provided by GNSS constellation directly inside a behavior model. We also provide various systems to record data directly inside the equipment or to push data inside the cloud environment, and vibration, odometry, and acceleration system allowing to make some artificial intelligence experimentation in real conditions. So for this activity, we have an hardware solution embedding first of all processing unit very performant at the state of the art with based on the Zinc UltraScale Plus solution from Xilinx, allowing to embed processing unit based on the IRM Cortex i53 and an FPGA allowing to develop very high-speed processing calculations, very important for artificial intelligence or also for vibration acoustic analysis. The last part of the processing system is that we can also embed deep neural network accelerators based on the Intel Movidius solution, which allow directly to embed artificial deep neural network calculation and inference directly inside the embedded equipment, and reduce, for example, the data stored for example, post-processing. We can reduce the data that will be useful and interesting to store inside the equipment. Concerning the external input-output and sensors, in the base solution, we provide various sensors such as GNSS, EMU, temperature, humidity, directly inside the equipment that allow to provide more information in case of prototyping about the environment context when we store and we measure data of our new technology. And we provide the connectivity to use Ethernet connection, various serial link, and also wireless connection such as Wi-Fi or LTE for the most important technologies used currently. And also, in order to interact with the rail, the train, we provide discrete, analog, and relays directly inside the equipment in order to interact with the rest of the world. Also, this hardware and this electronic can be embedded inside various form factors. We have developed different form factors in order to be integrated in different environments. With different options and different functionalities. For example, in the bottom we can get a small box embedding Ethernet connection and various discrete input-outputs, and which is compatible with many trains and voltage that we can see in train conditions. And on the top, it's middle top, it's an equipment allowing to do a GNSS localization, but also LTE connection in real time, and embedding directly the antenna on top of the box, which allow to use this equipment without doing a lot of engineering on the cable on the cable circulation inside the train. Next one, please. Thank you. So this is this equipment first is based on a solution allowing to work inside a simulation environment, develop an application inside, for example, MATLAB Simulink, and put the various input-output that are provided by the equipment, developed a software inside a simulation environment, and once this software has been fully tested in full simulation, it is possible to take it and directly embed it inside the real equipment and test it in real condition. We provide inside the equipment every calculation required to translate the physical signal to engineering values. Oops. And we provide in this equipment a maintenance interface, allowing, for example, to visualize in real time important values that we want to monitor. That's a very important thing when we are installing the product inside the train. And we also provide interfaces allowing to quickly update the behavior of the equipment directly without removing it from the train, updating a new firmware and put it again in the train. We can directly update the firmware by using a Wi-Fi connection, for example, and check if it's working and very quickly update it. It's a very interesting features for rapid prototyping and to allow incremental development of the behavior of the equipment. Next one. And the last one, we provide to the end user various user interface, for example, a map allowing to see where the equipment is located, and also a very high-level programming language allowing to define very easy calculation in order to make a dashboard of the more important information that we want to see when we are trying a new prototype inside the system. Thank you very much.
Well, thank you again for your presentation. It was the last of the day, so thanks again. Any questions, maybe? Well, and maybe one question. So how can you help rolling stock manufacturers and system integrators with your solutions?
So we can help manufacturers by providing a solution allowing to very quickly test a new software inside an already qualified equipment. And so moving a little bit from a V-cycle development with a very long time between the ID to the test inside a real environment to an incremental development where we can put directly inside an already environment qualified equipment to the new software.